Alright, the next part asks us to complete some code. I'm going to put the code on the board. I'm going to delete the top part so I can start writing. Alright, so we need to complete that to make sure that we can merge. As far as she gone. Okay. Alright, so remember the merging process is just what is putting the two lists together, assuming both lists are already sorted. So if this one is null, then return list 2. If list 2 is null, we return this one. So we've taken care of the cases where either list could be empty. So for the rest of the cases, we know that there's data in both lists, so we need to compare something. What do we compare?
We're going to compare parts of it.
Which parts? The first item in each list, right?
Right.
So we get the first item by using which function? Right. So if car of list 1 is less than car of list 2, then what are we going to do? Join what?
The first element from both lists. Yeah.
Well, you're going to take one of them. If the first item in list 1 is less than the first item in list 2.
Okay, then you're going to choose list.
You take the first item in list 1 and you join that to the result of merging the rest of the list. So we're going to cons car of LST1 with the result of merging the rest of LST1 with LST2. Else
So you're joining with all of LST 2?
Yeah, because we only looked at
The first element in
the
LST?
first element is that is less than, so we're joining the first one from the first list to the rest of first list to all of list two. Because we haven't taken on anything out of list two.
Okay.
Else, if this is not less, but if it's greater than or equal, we just take the first thing in list 2 and
Change the graph at the
do a
same
similar operation.
So you just read
Cons car of LST2 with the result of merging the rest of list 2 and just keep the sequence of the arguments the same. So LST1 with critter of LST2
You know, I thought merge was a function, was a special function. Maybe like it's in the function. So calling it back again and
you want to go over it?
enjoying.
I'm going to take off the top part so I can start writing for the next one. So next we're asked to complete the rest of the merge sort. Now we're told to assume that we already had a function that could split the list into two halves. We won't bother to write that right here. So we'll define Alright, so all of this is already on your tutorial sheets. So I'm just going to get to the section where we're going to complete, and then we're going to work with that. Put this in the same line, save space. So, in English, this first checks to see if the list is null. If yes, return the empty list. If there's only one item in the list, then return the list. Then we check to see if there are two items in the list. And if that's true, we check to see if the second item is less than the first item, in which case we'll swap them. So, all up here, these are the base cases. Now, down here, we have the general case. What we need to is split the list into two parts, left and right, and then we do something with those two parts. What do we do?
Split them then sorted.
Remember the merge sort works. We split them, we
Okay.
call the merge sort on them, and then we merge them. So what we need to do is call merge on the result of merge sort on left and merge sort on right. So what we have is merge so merge takes two lists. Set.
So we split them and split them, call merge sort, which was sort and
So what's the lambda?
it's a function.
That's a function.
Yes, it's lambda. You can use lambda when you have a function that you're not ready to put a name to yet.
That's what I saw
Different.
first, you know.
It's much different, I think.
Whatever that to be done there.
Alright, we're going to just do the quick sort question, and then we can do the radix sort when we come back from lunch.
We were there. We were there.
Alright, ready for the quick sort? Now the operation of the quick sort is to choose a partition element. Quite often the partition element is chosen at the first thing in the list. And then we reorganize the list so that everything that is smaller than the partition element is in front of it and larger than the partition element behind it. We then run a quick sort on the first part of the list and a quick sort on the second part of the list. So
That's what similar to what we just did there.
It is it's a recursive procedure, but one key thing of the merge sort, one key thing about the merge sort is that it's not an in-place sort. You make copies of the data as you go on. So if memory is an issue, you don't want to be using the merge sort. The quick sort is in place because we're actually just copying the keys around.